We left off in part 1 with this page right here looking at the second bullet point under our objectives of distinguishing composition. And composition is related to the atoms that are within different minerals. If you remember from Lab 14 where we looked at igneous minerals, we had our minerals grouped into dark colored or mafic minerals, and that included olivine, augite, hornblende, and biotite, and the light colored or felsic minerals, and that included plagioclase, orthoclase, which are both feldspars, muscovite, and quartz. And here we have the principal cations or positive ions that are in each. General rule is that the dark colored or mafic minerals have iron and magnesium in them. The felsic ones do not. In this lab, we can look at these different minerals in Bowen's reaction series, which is shown here and on page 83. At the top here, we have the first minerals that crystallize as the magma chamber is cooling, and that is shown here by temperature. High temperatures of 1300 degrees centigrade down to about 600 degrees centigrade. The first minerals to crystallize are mafic minerals: olivine, calcium-rich plagioclase, and augite. These are mafic in chemistry, and the color overall is dark. Even though olivine is a green mineral, it's considered a mafic mineral. In fact, it's actually an ultramafic mineral. As we go down in temperature, we come to the intermediate and then the felsic minerals, which are the last to form as the magma cools. These are the light-colored or felsic minerals and tend to be white or possibly pink. So color is a good proxy for composition of minerals. Here's that chart we looked at before for naming igneous rocks. Last time we looked at texture, which was given in rows. Now we're going to remove that, and we're going to look at composition, which is given in columns. Here we have our felsic column, and again, these are usually pink or white in color, and the rocks that we'll see include granite, rhyolite, and obsidian. Now this is a little tricky because obsidian is a black rock, but it turns out that compositionally it's felsic, so it sort of breaks the rules. Then we have the mafic column over here, and those rocks are gray or black and include gabbro and basalt in our lab. We have an intermediate group here, and these are either gray or, when it comes to the coarse rocks, black and white, salt and pepper sometimes we call them. And those include diorites, and then andesites are the volcanic equivalent. We're not going to worry about this column right here because it's kind of a combination of the felsic and the intermediate, and we don't need to go into that kind of detail for class. We are going to include this last column over here, which is the ultramafic or dark green group. These rocks are actually representative of the mantle. The one rock that we have in our lab is peridotite, which is an ultramafic rock. So once again, if you have a PCC rock kit, take the 9 rocks and try to put them in 4 different piles: a felsic pile, an intermediate pile, a mafic pile, and an ultramafic pile. And in this case, you're going to base it on primarily color, unless you feel like you're pretty good at identifying olivine, augite, and quartz. Pause and put your piles together. Okay, here are the answers. The felsic ones are numbers 1, 7, and 10. And these are the ones with a lot of quartz, or in terms of the fine grain ones where you can't see the minerals, they're sort of a pink color, like number 10 here. Number 7 is that glassy obsidian that looks black, but in fact it is felsic. The intermediate ones are number 4 and number 17. 17 has that salt and pepper look that I was talking about. The mafic ones are 9, 20, and 23. Number 9 is a special one called an anorthosite, and we'll talk about that in a bit. It's mostly calcium plagioclase, so it looks light colored, but it's a mafic rock. And then finally, those green crystals on the edge of number 21 are ultramafic. Those were those olivine crystals I was talking about. So before you get started on identifying the rocks in the lab, there's the pre-lab questions to answer. And you should be able to answer all of these. The first section asks some basic questions. Questions 5 through 12 ask about the composition temperature diagram in figure 2. Well, that's this diagram right here, so let's take a quick look at it. What we see here are intrusive rocks listed in this column, extrusive rocks listed in this column, and again I've highlighted in yellow the ones that we're going to be focusing on in lab. You can basically see that compositionally we have equivalents across from each other. So this is a little bit sideways from the table I showed you before. Textures going vertically, compositions going horizontally. We also have some rules of thumb over here in terms of what direction on the table rocks are lighter or darker, what direction silica increases, and what direction melting temperature increases. That temperature is also listed over here. And then this chart right here tells you the range of mineral compositions that you might find in a given rock. For example, a gabbro is a coarse-grained mafic rock that has calcium plagioclase. It could have some amphibole. It definitely will have some pyroxene and a significant amount of olivine. The same minerals can be found in basalt. In fact, gabbro and basalt are sort of like brothers. The only difference is basalt is fine-grained and gabbro is coarse-grained, but compositionally they can be the same. And this range indicates that some of these kinds of rocks may have amphibole and some might not. Up here we have the ultramafic rocks, and peridotite, a rock from the mantle, is mostly olivine, a little bit of pyroxene, and some calcium plagioclase. The felsic rocks down here, such as granite, have quartz, potassium feldspar, a little bit of sodium plagioclase, muscovite, and possibly some amphibole. So that's how you read this chart. Notice that there are some points over here. Number 1 you don't have to worry about because we're not going to include dacites in our discussion. But remember that any intrusive or extrusive rock could also be porphyritic. Don't worry about number 3. Pyroxenes are also the mineral that we've been looking at called augite. Amphibole is the mineral we've been looking at called hornblende. And K-spar is short for potassium feldspar and also called orthoclase. That was for these questions 5 through 12. Questions 13 and 14 ask you to look at this flow chart. And so this is a flow chart that you can use to also help you with the texture. You start here. Can you see any crystals? If you cannot, then you come over here and use one of these choices. Aphanitic, which I've been telling you just to use the word fine-grained. Pyroclastic we're not going to use, or glassy. So that's pretty straightforward. If you do see crystals, then you ask yourself, are the crystals all about the same size? If they are, then you have a coarse-grained rock. If they're not, then you have a porphyritic rock. And then you ask, what's the size of the crystals in the ground mass? In other words, is this a fine-grained rock that has a porphyritic texture or a coarse-grained rock that has a porphyritic texture? And so we went through this before and we talked about how we can just say it's a porphyritic coarse-grained rock or a porphyritic fine-grained rock, and we're not going to use pyroclastic. So that's what you'd want to look at for those questions in the pre-lab activity. Finally, the last set of questions asks about figure 4, which we've already looked at, which is this chart right here. The questions might ask about some of the other rocks besides the ones I have in yellow, but that's just to make sure you understand how to read the chart. So remember, textures in this column, and we're not going to use pyroclastic. Compositions in this column, and we're not going to use that felsic intermediate column over here. After you've done the pre-lab questions, the next video is going to move on to looking at the actual rocks. Yay!